Okay, please listen everyone. Just for 1 hour, okay?
Today just start some basic program about the neural network. Okay, just I give the very basic. I not go to the details about the neural network large program. So we just starting the in the MATLAB how we actually use. I not use the toolbox. Again, I repeat, we not use the toolbox of the system. I just consider the how you write the neural network program into the MATLAB. So you would most probably know the little, you know the neural network structure. You just the idea, neural network structure. So when you actually go to the neural network structure wise, you can understand this thing. There is the three part is there in neural network. There is three part is there: the input, output, and the hidden layer. Okay, the input layer is actually totally depend on the how many input you consider from your outside. Means the how many input that is not in your hand. Again, I understood this thing. Input number of input node in the neural network is not in your hand. How many input you want to the your system, that is totally depend on the system to system and problem to problem. Similarly, the output also depend on the how many output you want from the neural network. Only in your hand is actually the hidden layer. Mean the when we design a neural network, so that is the your in your hand only hidden layer. So you can use the multiple hidden layer in your system. Understood this thing? You can use the multiple hidden layer in your system, or you can use the single hidden layer. If you use the multiple hidden layer, your computational time will be increasing. Now, when you actually go through the after choosing the hidden layer, your next step is that you can choose the weight matrix. That is the initial weight matrix in your system, and form the weight matrix in your hand. Means the you can put the initially the weight matrix, and depending of your learning algorithm, your weight matrix will be changes, and then we got the output. Means the different of the learning algorithm is there. I not go to the details. Back learning algorithm is there. Mainly we 85% problem we actually go to the back algorithm. Now we understood this thing. When we actually go through the any neural network part, a neural network part. So first is actually the number of nodes, and between the number of nodes and the second, if you connected the your input node to the your next hidden layer, between the your input node and the hidden layer node, when they will be connected, they will connect it to the weight matrix. And different the activation function is also you can use for the increase the depending of your nonlinearity in your system. Either you can when you can consider the MATLAB, you can see that the GL step type is there. You can consider the step input when you consider just your one and zero. So that is actually we consider hard limit. So different type of the function is there. So how actually use? I not go through the again. I repeat the two type of the there. One is you can use the toolbox in the MATLAB. Another way you can use your own programming. I just see the how actually write down the your programming part. How you write down the program into the MATLAB toolbox. Means the, in the MATLAB command window. Means the how actually you can consider the MATLAB command. So first we actually start. So one by one I actually discuss about this thing. You can see that this is visible. Yes. And we actually consider the calculate the output. Calculate the output of a simple neurons. Okay, means the you can understand this thing. So we find out the number of nodes. This is another node, and this is actually connected between nodes. This weight matrix is connected. You understand this thing. When you find out the neural network structure, similarly, different type the this type of the weight matrix is actually connected. Yes. If the 1, 2, 3, 4 you can consider. So this is the W11. You can consider W11. This is actually the W12. Similarly, you can consider W13. Similarly, here the W21. If this is connected to the W21, so this type of the suffix we actually use. So here we actually consider the how we actually got the output. Whether this is two neurons, we actually consider the weight matrix is connected in your system. So how actually you can calculate? You understood this thing? If problem discussion, calculate the output of a neurons actually. So first we understood this thing. We actually two input we actually consider. It, everybody most probably little bit idea about the MATLAB also. Yeah. So we actually find out the close all, clear all. That is actually the this thing actually the for the your basic CLC the clear the command window. If the any previous data is there, they clear, and the format compact is actually the compact we actually use. Even the format is there. So here compact form is actually the output we actually consider the compact form. So we actually considered here. You can see that the two thing is actually considered. One is the weight matrix. Another we actually consider the bias. This is the B. We actually consider the bias here. So we actually consider neuron weights 4 and minus 2. That is we consider neuron bias is B equal to minus 3. And we actually use the different of the activation function between the input and output. We actually consider the different of the activation function. So here the four different of the activation function we actually consider depending on the availability MATLAB. This is you not write down this thing because when you consider the C++, you can write down the your own program. But there is some inbuilt function is already available to the MATLAB command window or in the MATLAB environment. So that you can either you can use the TANSIC, Boolean, hard limiter is just like a step input. You can consider the log stick, depend on the input with you can I just post one by one. Then you understood this thing, what is actually the function we do. So we actually first define the one output P equal to input. So the two input we actually consider P equal to 2, 3. Now the calculate the neuron output, you can understood this thing from this. So if this is the your input, this is your input, the two input is there. So depending on the input, we actually consider the PW plus B. So here the input is actually the your input. So the two input is so PW plus B. So you can see that we actually consider the PW. This is actually W where the two is there. So we actually go to the transpose of the this system. Then the neuron output is F eval. Eval means actually the already any function we actually consider. Eval function actually the evaluate the your function value. So to understand this thing, what is our function here? Function we actually consider the which type of the function we actually consider from the here. Either this is the function we actually consider the log stick. So we actually find out here log stick activation potential means this function. Your output in your system activation potential, and then we actually go through the you can also find out the how many data you want to get. Here I actually consider I can consider here the by default. Okay. Then we actually consider P1, P2 means get. So this is actually you can go to the P1, P2 means the when it draw. So we actually consider minus 10 to 10.25 interval. And then we actually consider again we consider the eval function P1, P2 means the first initially we write down the program for the only a particular function. Then from the range of the P1, P2, if we increase the range of the P1, P2, then we actually find out the what is the our output of the function. Then we find out the recept and the plot of the P1, P2, and that is actually also if you run the program, you can see that the so you can say the minus 10 to 10 we actually go through. Similarly, minus 10 to 10, and the output is actually considered that this is the our which function? The function we actually consider here. The Boolean what is actually you can consider from this here the log stick. Log stick. This is actually the structure of the log stick. So you understood this thing. We actually find out the your programming part. Similarly, if you change the function, you understood this thing. If you change the function, suppose instead of the we can consider the tan stick. You will change your activation function. You can see that the our format is actually changes. Means that you can get the output. Similarly, If you go to the hard limit, so this function is also changes. Just like a 1 and 0, this you can see that the 0 and this is coming to the 1. So depending on the your function name, you understand this thing, the output is changes. So you understood this thing. We first we go to the input value in the MATLAB how actually write on the neural network. This is a very basic first step in the our neural network program. How actually write down the first we actually choose the basic input, then we actually choose the weight matrix. Here not I can go through the any learning algorithm. Still I cannot. I can give the what are the step by step how this is actually coming. So when the input or output, the function is there. So that function we actually consider the P into W. This is why we actually consider W just like the dot means. Actually, this is actually just anybody, but this symbol is actually represent anybody. Why we actually put that this dash in the MATLAB? What is actually this? This is significant. W suppose 1 2. P is actually also give the 2 3. Suppose. Why you actually put the this symbol? What is actually represented by this thing? Transpose. So you can understand this thing. This is actually you can represent in this way. We can multiplication into the in this way. The transpose of this system. You can put the value into in this way. When you get transpose, just the matrix multiplication. Then we actually put the your B value. Adding the B value. So this is actually represent. If you understand this thing, if this is your P1, P2, this is W1, this is the 2-1. So then we actually consider P1 into this into this plus B. So this is actually give the your overall value. So that one we actually the transpose the value. You can see that the your weight matrix we actually represent 4 by minus 2 and the P value also the this value. So that one we actually put the transpose of the W and then we actually find out the potential. This is the eval total function and then you got the output. So this thing is clear. Mostly I just starting very basic. This basic thing is clear. So how actually use the neural network? How actually find out the output from any node? You understood this thing.
Then what is on what basis we are choosing the activation function?
Activation function is a system non-linearity. You understood this thing. Similarly, how actually I go through the our cases real time how actually choose the activation function. If when you can consider neural network, every time you have the your input data and also output data in your hand. You understood this thing? Input and output data in your hand. So mathematical relationship is not possible. Every time you actually not find out the mathematical relation between the input and output. This is not possible. Again, this is not possible. Every time we can find out the correlate. Sometimes we actually from the mathematical expression is there, and then from that we actually generate data. That is actually then you not use the neural network. If you have mathematical expression is there, then what is actually got? If you know this thing, you already modeling the system. When you cannot model the system, there we actually use the neural network. So what should we do? You actually first find out. You understand this thing. Suppose you have the 1,000 data in your hand. 1,000 input data, obviously the supervised learning, the 1,000 output data is in your hand also. So first we actually find out how they will behave for the input and output. Mean how the nonlinearity is actually coming in your system. You can see that the system nonlinearity is very high. So your activation function is nonlinearity. You can also get because you can nothing. You can actually create the nonlinearity in your system. Activation function is nothing useful. You can because if you find out the input and output relationship between the input and output relationship, we actually put the activation function. So if you draw your system, you can see that the different of the input data in your system and corresponding your output. If we draw the 1,000 data input and output, if we draw, you will see that the nonlinearity of the system is very high. So there we actually depending on that you can actually find out the nonlinearity in your activation function. We actually use the activation function. But if the nonlinearity is not there, so hard limit function. So there is actually only 0 and 1. So there we not use the So this is just like linear system. If the just like clustering, if this, then this part and this, if you can actually just clustering the your system. So there we actually not put any non-linear system. So there we use the hard limit in our the system. So depending on the your system behavior, we actually choose the your our activation function. Second, we actually put the second part. Now actually you can find the network. Next part we actually go to the first, we actually go to the second part, how actually choose the network in our system. That's how our neural network, what is actually different part. First is the actually the network architecture of the neural network, then the training. That is the some part in your neural network we actually go to the second part is that how actually you can go in the MATLAB, how actually you can put the network. Network is the system. I not go through that very small programming actually I can consider because first you actually understood this your basic will be, then you actually go to the large programming. Otherwise you not understood this thing. So first you can see that the define the problem, create and view the custom neural networks. Understood this thing, custom neural network. So this first programming flows or CLC format number, the same thing is actually we can use. You know this thing. This is a MATLAB common thing. Is clear all means actually the all the clear the all the value from the your MATLAB compiler or window is the command window. Close all means the all the if the any figure is there, so there all the figure will be clear. CLC clear the command window, and the similarly same format we use the format compact. Here we actually input we consider the 1:6, means the 6 input we actually consider input vectors. First anything you when you can MATLAB first the input and we actually record the output and the weight matrix. So output is actually you can consider two corresponding target output. Now actually how we go to the customized networks, you can see that the how actually put the network. Inbuilt network is there in the MATLAB. You can consider the NEFF, new FF, that is actually the feed forward network in the system. But if you use your own network, you will customize the network in your system. So how actually we can put this in your system? I can give one small example also how actually you can put the customize. So first you can consider here the number of inputs, one, number of layers, means that we actually consider the two. Bias connected means that internally bias connected in your system if you consider the two input in your system. So when a hidden layer you can consider the two nodes, so the two bias is there. So this is actually the bias connected number layers one by the Boolean vectors. Similarly, we actually consider the input number of layers we actually consider. So this is the layer and this is actually you can last to actually consider the output connected. So by default you can choose this thing, otherwise you can corresponding you can only put the your 1 and 2 and mean how many input is there, how many output is there, how many layer you want. Everything is actually by default they will be taken. If you want to choose the your system, you can actually inbuilt into in this way with the net, and then you can. So if you don't understand this thing, you can actually put the help net in the command window. So everything is format will be actually coming. So next we actually find out after you can put, we actually find out the view the network structure, means the how the network will be structured in your system, means the total network. View net is actually the how you can structure the network, means how many node you can consider input node, output node, between the input and output, how many weight matrix is there. So that is actually you can see from the your network system. Then we actually use the your topology and the transfer function. So number of layer we actually consider the number of hidden layer neurons. We actually consider the 5 neurons in your hidden layer, and the hidden layer we use the transfer function. This is the structure. You can see that there is a log 6. Then again, first we actually use the number of layers input. Then we actually consider the network we actually put. The next step is actually you can consider in the hidden layer how many nodes you want to do. So that is actually we can put the this command net layer size 5. Then we actually consider transfer function between the log 6. Then we actually find out the our commands. The output means the how actually you can consider the view net. Then again we actually configure the networks net configure. Now the net means the network after we create the total network. Then the inputs and the outputs. then the view net. So this way, up to this thing, we actually structure. First, we understand the input. We actually put output. We put. Then we can find out the input output. How many weight matrix you want in the hidden layer. How many node you want to do. You record. After you can put the, then we actually find out the total view net. So this is actually, we can consider input, output, and the network structure. Our next state is actually the 10 the network. After that, you can put the network. So next is 10. So 10 net and calculate the neuron output. So you can see that the initial output means the without 10ing, we actually find the initial output net inputs. Then we actually find out the, this is the inbuilt function we actually use, the net dot 10 function, 10 alarm. So we actually net MSC. Then we actually find out the 10. This is the command net 10 net input and output. And then we actually find out the final outputs in the net input. So if we run the system, you can see that step by step I just put three part. First three network we actually consider view net, 3 times we actually consider. You can see that sorry, this is the then the network. First, this is actually the, we can consider the layer. You can consider, we can only choose the layer 1, 2 hidden layer we actually consider. 2 hidden layer is actually coming. Then you can see that we can consider the 6 input. Initially we can this is 6 input. This is the final. 3 networks we actually consider. First we only consider the our hidden layer. Then we actually starting from the your how many layer in the particular layer, how many nodes you can want. You can see that the here the 5 and 2 hidden layers. So we actually consider the 5 nodes in the system. So 2, and then we actually find out the 10 the network. 3 step we actually consider from the net view net. You can see that one of these 3 is coming. So you can see that first we actually consider only the view net. Okay. First we actually consider only we find out the network structure. Second one we actually consider number of hidden layers. Second layer we actually consider number of layers 5 and the 2. So this is the second one, and third one we actually consider the 10 the. This is the final output. This is the your 10 the network. So this way we actually write down the your you can create the your networks and you 10 the your system. The third program we actually consider that this is the very perceptrons in use. Anybody any idea about the perceptrons? Linear separable perceptrons. Anyone neural network any idea is there? The perceptrons is actually we are actually linear separable. So just like the if we consider the your linear separable, suppose I can consider the everybody little bit of the Boolean algebra.
Yes.
And not or XOR. Eh? When you consider and or, so this is the linear separable. So when you can consider XOR, this is linear separable or not? Not, because you can consider the if it though the your 2 input and output, you understood this thing. When you consider the and function, 1 this is the 1 0 0 0 1, this is the 0, and 0 0, this is also 0. Similarly, when you can consider OR function, so if you draw the your 2 inputs and corresponding your output, you can see that the your system is totally linear separable to each other. But if you go to the XOR, this system is actually not the linear separable. So that techniques actually, I not go to the details. This is the little bit. So that technique also we actually use for the our when you neural network structure initial stages, we actually find out the what is the different perceptrons in the system. So inbuilt function is there. Idea just go to the how you write down the your own programming in the network. So you can see that same way we actually write down number of number of data is actually sample of the each class, we actually consider the 20. Offset is equal to 5. We actually here we not consider the input data, randomly we actually generate the data. Okay, so two inputs we actually consider. Random 2n means the number of sample we actually consider. You can see that when you can put the offset, so these two data will be actually different. You understood this thing? When you actually generate data for the corresponding for the input, either you can actually call the input from your any system, then you actually see that your system is in a separable perceptor. Otherwise, I just generate the data for the. Similarly, we actually consider the two parts. The y we are on consider 0 and the ones. Means that two will be separate. So this is linear separable or not. From the your input data will be linear separable or not. So we actually dot the figure 1 and plot PV. Yeah, you understood this thing. This is actually you can dot the when we can use the perceptron data. We actually consider the perceptron inputs and the target. So this command we actually use for the in a method plot PV. So this is we actually find out that x comma y. You understood this? This way we actually put the your system. Then we actually find out the net perceptron. Net perceptrons we actually use. Net 10 perceptrons we actually when use we cannot go to the because this already inbuilt command is there. We actually not go to the any network by the customized network. Either you can put the customer when you can perceptrons network we actually use the your inbuilt program. So we can actually use the net perceptrons. Then you actually tell the your network. So this is the net 10 net comma x comma y. Then we find out the view net. Then we actually find out the figure 1, and then after the you can put perceptron network. We actually plot PC the your weight matrix as well as the VAS. So how actually you can see that how they will be coming. I just not go to the 10 the network. I can just only use the perceptrons network. So how they will be. So you can see that this is the two values there depending on the input they will be separable to each other. After that when the 10 the network when the system will be classified they will be actually you can see that this will be actually occur. So how this system is at the which point mean the after that they will actually which point the system will be classified to the each other. The vector will classify. So randomly they will generate data after the perceptrons network. So we actually find out the how linearly the system will be classified. So in this way we actually write down the your program. You can see that structure of the structure of the program is there. When we use the system actually inbuilt function when you use automatically they will be 10. How many epoch is there? So by default I cannot choose here. Up to still you can see that in the training purpose we actually not put anything. How many epoch is actually you would what is your which point the system will be actually converse that will not put by default that will be take. But we just use the your neural network inbuilt function. By using the inbuilt function, we actually see that the how actually you can use that inbuilt function for write down your own programming part because in the research purpose you can actually learn this thing. But initially structure you should know how actually use that MATLAB into the when you write down your own programming. After that we actually not use the how actually you can data will be you can actually extract from the MATLAB. So now previously we actually considered the only the mat file. Nowadays actually XLS file, PDF file, your Word file, every file you can your image file also you can extract the data from your system. So that you should know the which type of the command we actually use for the data extraction from the your input as well as the output. Excel sheet, how what is the command? Suppose from the Excel because lot of in the Excel file nowadays actually our main data input data will be suppose we want to the in the Excel file we feature the data from the Excel file. What is the command? Anybody? Understood why I say? So suppose the your Excel file is the input and output data in your hand. How actually can Here actually I just manually input, I give the P and Q, but in the suppose the 1,000 data will be in your has 10,000, 8,000 data. That is not possible to the typing the all the data. So how actually can extract the data from your Excel file? What is the command?
There is one for Python, like for pd.read.
Okay. In the here XLS read command is there. XLS read command is there. So from that we actually extract the data from here. So here the command is also there. Actually, I just gave the little bit where you can concentrate. Everybody is actually not understood about the file. So MATLAB is the inbuilt command is there. So how actually use this command actually? That is my main aim. Okay. Before we go to the another programming part, I give the one small example. Then it means that suppose in our cases, this is actually the initial stage. Suppose we actually take any type of the value. If you have the this program is very much useful if you have the input and the output, means the customize if you want to the system. You can understand this thing. Suppose I give the very small equation y equal to a square. Just like the our we just square the value. If the x is there, so you can see that the 8 value we actually consider 1, 2, 3, 4, 5, 6, 7, 8. Similarly, we actually consider the square. So 1, 4, 9, 16, 25, 36, 49, and the 64. Just like we actually now, if you take your networks within the input, if you put the any value 1 to 8, if you put suppose up to you can see that we can only consider the 8 value between the 1 and 8. If the system will be 10, you can put the any value, you can got the corresponding output. What I say, you understood this thing. Suppose you can consider, you can put the input is 4.5, if the network will be 10. If you put the input is 4.5, you can got the corresponding your output. If you consider 4.2, so you can got the corresponding output. So how actually you can put it? Because any input output data, how it should be 10. My aim is not that this system, how actually you can proceed. Suppose you have the, every time you can consider that this is the neural network. So first step you have the data, input data and output data, how actually you can proceed. That is the your first. So initial stage, you can first, here you actually put the P and T. That thing is actually you can, you if with 1,000 data, this is not possible to the input the data. So there we actually consider the P, XLS read your particular file. So they will actually consider the P value. Similarly, the target value P also Excel read. You can actually put the particular value. They will be extract from that your XLS system. Similarly, you can if you put the your DAT file, you can actually put the load command is there. So you can actually put the load the particular file. So that is actually also you can actually put the first you actually select the your input and your target. That is your first aim. You understand that? That first stage is the neural network is actually the you can put the your P and the you can actually select the your P and that means the your input value as well as your target value. If the supervised learning is there, I can mainly consider the supervised learning. So if you put the you can put the P and then P. Then we actually consider the feed forward. Backwards algorithm we have a new FF. This is the inbuilt command is there. You understood this thing? If you not understood this thing, how actually write down this thing? So you can see that you can put the here in the MATLAB. You can see that the new FF is that create the feed forward backwards network. Okay. So the all the system is actually given to the system. So here you can see that the P, T and the S. P is your input, T is your target, and S we actually choose the size, number of hidden layers, how many hidden layers you can want. So this data will be actually required. So you can see that we actually use first we actually P comma T initial value we actually plot P comma T. Then we actually put the net in a new FF P comma T 3. 3 is number of hidden layer. We actually consider there is a structure P comma T comma S. So here also you can use the your input P comma T comma 3. Y1 is the sim net comma P. Sim means the simulation the network. We actually sim the net comma P means the Y1 means the initially without any training, without any train the network. So if we consider the P, the how the your arbitrary we actually choose the network, how the system will be coming without the net, and that we actually without the train network we simulation the, and then we actually find out the P comma T. This is the your O. O means actually your initially the target value input and target value, and that is for the your without the training how is the output. So this plot you understood this thing. Two plot we actually draw as the your input and the target. The same chart we actually draw also your input and what is your network output without the train the network. The next we actually consider training the network. So we need 10 params through 3 net command line we actually put 3. So this is actually epoch. Here you can see the number of epoch. Goal means actually the when the system is actually convert. We find out the gradients. So this is the different or you if you don't understand you actually use the by default. You use this thing otherwise you by I can consider what is the difference value is actually there. So that one we actually if you don't understand initially cases initially when you can start you actually consider the by default. When you program because this small program that is not required. When you can go through a large programming your non-linearity of the system at that time actually you can choose all these things. But if initial stage when you actually start you write down your neural network program you are not recording by default you can actually take the network. First you can see that how the output will be coming. Then one by one you understood these things so how the different parameter what is the significance of the all the parameters. So here you can see that the number of epochs actually maintained and number of goals. That two things actually very much important in the neural network. Means the epochs means the all the data, how many when the system will be combined, means the number of iteration. How many iteration, all the data will be how many iteration you have required to achieve the goal of the your system. So either the your number of epochs will be achieved, your system will be terminated. If the goal also achieved, then your system will be terminated. This is the two terminated condition. Goal and the your number of iteration, number of epoch. And then we actually consider the train the network. Initially we not train the network, we actually go to the output. So next one is actually you can train the network. After that again I sim the network. After training the your network, initially without network, then y2 is equal to sim net comma p. Then you can plot p comma t and p comma y2 into x. Then gen same is actually the network. We actually generate the network. After that we actually after that the you can understand this thing by graphics, by simulation model we actually put the overall system. So if you run the system you can see that initially you can see that this is the your input and this is the our output without the train the network. After train the network, one minute. now you see that initially value there is no target. After that you train the network, your system will be output will be converged. Both the output two curve we actually do first without the 10. So you can see that at that time your target value and output value is not matched. So after 10 the networks, you can see that your target value and your system value is actually will be matched to each other. So this is our final model. You understood this thing. So they will be generate the input, output, and your custom neural. Now, if you put the any input between the 1 to 8, if you put, you can got the corresponding output in your system. So this is the final generation in your system. Again, I repeat, you understood this program. This is the very customized neural network program, very small customized neural network. You can first put the P and T, just like y equal to a square. Where you not go to the simplified your system y equal to a square. So 8 input is there. Similarly, the y equal to a square, we actually put the 64. So first we actually plot P comma T. O means actually this is actually just for the symbol. Symbol we actually represent it. So they will be draw the your system. After that, we actually go through the your backward algorithm. So this is comma P comma T up to the three hidden layer we actually consider. Then we actually draw without the you understand this thing without the 10. Just first plot you can see that your x that cos and the O is not matched. So that is the first plot without the 10. So we actually simulate the total network. Then we actually define out the training parameters. Again, I repeat, if you know, you can actually choose. Otherwise, by default, they will be actually train your network. So mainly important thing is actually how many epoch you want and what is your conversion function. So after that, when you can put, you actually number of 10 params we actually use number of epochs and number of 10. These two parameters actually here we actually already consider. You can see that number of epochs we actually consider 100 epochs, and again we actually consider the. Then after the training, again I train the training. So again I simulate the network. Then we actually draw the system. What is last? You can show that in the figure 1 and here both of the figure because this is the superimposed. So the figure 1 and figure 2. The first one is actually without 10. The second one after the training. So then we actually put the GenSem is equal to net out. So you can see that if you run the system again, I repeat. You can see that the figure 1, the system is actually the first one without the delta network. Now this is the final. You can see that this is the final output. Now you to understand how actually you can go through this thing. So that in the neural net architecture, first we actually find out how many input is there, how many output. Depending on the output, you can put the network structure, and then we actually put the our means the last step is actually the you train the network, and then you can got the your output. This is the total structure in your system. So depending on the system, we actually go through the different I just put 2 and 3 is not this. So you can see that the classes. Suppose the 4 different of the classes column is there. So depending on that, so how actually you can put the different of the classes in your system. Similar previous we actually consider only 2 input. So when the multiple input is there, we actually use the previous perceptrons we use. When the multiple input is, we can actually use the ATAL line networks. We actually use the ATAL line network. So here we actually first generate A, B, C, D. And similarly, you can use the also the text value. So you can see that the four different, just like our function, you can understood this thing. If you give the program, understood this thing. This is a -1 plus because the 1 1 1 0 0 1. Just like you can put the our binary. Okay. So we can consider 1 1 0 1 1 0 and then 0 0. Here we actually generate just like this like just the offset actually. Q offset we can actually consider. Then you can see that this is the we can consider 1 1. This is we can minus we actually consider 0 1. This is the 1 0 and this is 0 0. Minus Q that we actually the four classified we actually different data we actually generate to your system. This is these four data we actually generate A B C D. Now how actually you can classify it? So we can actually consider the P equal to A B C D. That is we actually consider input. Similarly, we actually use the target value also. We actually generate. Then we actually keep the perceptrons. Same way actually previously I said this is the multi-layer we actually consider here. And then we actually find out the how we actually generate the network. As you give the program actually they will be understood this system. When you can one by one you actually put so you get that so how actually this thing is actually coming. Initially we actually class A, class B, class C we actually put. Then we train the network. And after that we actually find out the how the system will be classified. You can understand this thing. In this way we actually put the total network, generate the network. This is that you can see that the only the simple perceptrons hard limit we actually use, and then we actually generate the your overall system. Here we can see that the symbol is actually the hard limit. So number of input, number of output. Because the number of input 1 0 0 1 1 0, so two input is there. So we actually also consider the output is also. This is the output is actually 1 and 0 and the bias is also coming. So that one they will given the two output. This is the time series. We actually consider the output P1 P1 T2. Same way actually put that here. We run the network. Just the input output. First you choose the input output, then you can put the your network, then you can train the network, then you can actually got the output. And if you want to your simulation data, you can use the Jensen command. This is a very basic structure. First you actually put the input, you can create your input structure, then you go through your next is network, how you create the network, your next step is actually train the network. Your next after training the network you can actually simulate your system, you can actually create the whole network to the simulation model, and after that you actually put the any input value of the when you can testing the you can put either you can use the your own command window or either you can put the your simulation model, put the your testing data, you can got the corresponding output if the your system will well trained. Otherwise again you train the network and the whole the system will be going on. So first we actually see that your system will be well trained or not. So this is the you can we actually use the time series prediction this part. You can see that this is the network how actually you can put these things, and similarly the seven programming area. This is a again I repeat the previous two exam we not use the perceptron because linear separator. So when the XOR problem how actually you can solve, how actually you can use the multi-layer system, how actually you can put this is how so that we actually discuss into the this side. So you can actually same way we actually consider just only we actually use that to change the our network. So this is the feed for our net. Then you can train the networks, and then we actually got the output. So this system is actually solve the your XOR problem. So depending on your network structure, depending on the 10, your system wise also changes. So you first understood this thing, your input output relationship. Depending on the input output relationship, you actually find out the what is your network structure and what is your which type of the 10 you can actually consider in your system. So you can see that we actually find out the how actually we can find out the both. This is not linear separable. This is not the linear separable graph. So how actually you can write down the even the code structure is totally different, but they will be not linear separable to each other. So how actually you can write down the your here also the different of the clustering problem is there. So you actually so I just give the program so they will be understood this thing. Another thing I just small discuss about the because this is for your when you can actually go to the your research how actually you can use this thing. Previous class I can go to the ANFIS na ANFIS that thing is in the MATLAB the ANFIS toolbox is there in the fuzzy system that is ANFIS is there. So you can see that this is the ANFIS. This is the actually the neurophagy when you can put the ANFIS edit. So this type of the command in the neural net architecture, we actually use the fuzzy system. You understand that? In the ANFIS, we have what I actually say in the neural net architecture, we actually use the fuzzy system. So here you can see that when we just give the how actually use this thing. So here you can see that our input and target is there. For the training purpose, you actually do. Sorry. So training purpose, we actually load the data. Okay, where in the workspace. Either you can go to the your file if you input file is there, or either you can put the workspace. In the particular case, I can go. So we can see that the target file we actually create. So we actually put the input load data means that you can go to both the input and the target as one particular file, or your input file is there. So you can next we actually put the generate FIS. So we here we actually generate FIS. By default we actually consider FIS means the fuzzy system. First we actually consider the input data, then we actually use the fuzzy system. Here the number of membership function we actually consider F as the JPL set constant. So you can see that the FIS system, you can see that the structure. Total in the neural network model, we actually use the fuzzy concept. So their input command is there, output is there between input membership function, output and the rule base. After that, you can put the structure. Our next step is that we actually train the network. After we train the network, we actually stage our system. So you can see that our output and the is actually little bit. So this way we actually put the and his edit system. You can again I repeat. First we actually create the data set. Then we actually consider the FIS system, fuzzy system. Means we actually use how many input, how many output you can want either in the fuzzy system. structure, then you can train the network. By default, they will be actually training the system. We can actually define the algorithm is there. Either you can use the backwards and hybrid backwards, and this is the, so you can use this thing. Here we actually use the hybrid system, so you can train the network. After train the network, we actually use the test. So this is the basic structure of the entries when you can use. So first in the here we use the entry setting command in the system, and then we actually start by you also use the entries command. So this is okay. This is the your basic structure. We actually consider how actually you can use. Two things we actually and you can use the neural net small program. I can give the your program. You can actually go through this thing because the 1 hour this is not possible to the how actually you can go through the small. But when we can use the test command, that is very useful. So you can use your own file. In test, you can use your input and output your own input, and you can train that program. You can see that you can got the output in your system. Very simple way. I just write this program, so you can put the input. You can actually got the output in initial state. When your system complexity is increasing, so that you can also understand this thing how you can write down your own program, because every parameters you will not understood this thing in the MATLAB command window. You can put that what is actually the significant, how I actually write down the coding. Everything is actually the in the MATLAB command window. The help is there, so you can use that help also.
Okay. So sir, you will share the things. You may do it practice. Okay. Thank you so much, sir, for giving me precious time. Sir, we will have one clip. आप फोटो लीजिए. ऐसे आप लोग बैठे रहिए, बैनर के साथ आइए. ऋषभ आप पीछे आ जाइए तो आगे देखो.
सर इसको बंद कर दीजिए, इस पे फोकस मारा लाइट.
आप आगे आगे चलो ना. रिकॉर्डिंग ऑफ कीजिए ऋषभ. ओके, थैंक यू एवरीवन. 2 बजे से आपको लंच रेडी है. लंच कीजिए, उसके बाद हम लोग आएंगे. ठीक है. जो थोड़ा बहुत डॉक्यूमेंटेशन का काम लोग कर लेंगे हम लोग. है रेफ्लेक्शन जनरल वगैरह का है ना, वो देना. वो वाला फिर बचा है ना. ज्यादा नहीं, आधा घंटा आपका समझ लेंगे, 1 घंटा है ना. फिर आपको आज जल्दी छोड़ दिया जाएगा खाना खाने के बाद. ओके. थोड़ा काम खाना खा कर आओ. मिलते हैं 3 बजे.